Today, we're solving problem 25 from the fall AMC 10A of 2021. Okay. A quadratic polynomial with real coefficients and leading coefficient 1 is called disrespectful if the equation p of x equals 0 is satisfied by exactly 3 real numbers. Among all the disrespectful quadratic polynomials, there is a unique such polynomial p of x, except there's a bar line over it, for which the sum of the roots is maximized. What is p bar line 1? That's what I like to call it. Okay. Well, we're given some constraints. First of all, p of x, it's a quadratic polynomial, and it has a leading coefficient of 1. P of x can be expressed as, well, it's a quadratic polynomial, so it has 2 roots maximum. Okay, well, we also know that it's x minus something, call this r, and x minus s. Well, now, why can that be? Well, it's because r and s are the roots of this polynomial. And it also, the problem also states that we want the max, so p bar line x, this the sum of these roots are maximized, so these have to be minus, but they're really positive. Okay, well, now plugging this value of p of x into here, we have p of x minus r times x minus s. Yeah, this is 0. Well, now we can really just do something here. So this is p of x minus r times p of x minus s is 0. From this, we get 2 cases. Now, we were also given that that this equation is satisfied by exactly 3 real numbers. So that means that one of these have to have 2 solutions and one of these have to have 1. Okay, so let's call this one have 1 solution, and this has 2 solutions. Well, we also know that right here, we have either 2 successes, I guess. P of x is r, because they have to equal 0, and p of x, this is s. Now, we have to start with the 1 solution thing. This is a lot more complicated. But if you remember, any quadratic or formula that has 1 solution means that the b squared minus 4ac is 0. That's where it's 1 solution from the quadratic formula. Okay. Well, that starts to make a bit more sense. B squared minus 4ac equals 0, so that means this is essentially 0. Okay, so we can actually do something with this 1 solution. We're really interested in this because 1 solution is pretty peculiar. Now, earlier we let p of x be this quadratic here, but now, since we sort of solve for that, p of x equals r, we can substitute that value, that quadratic in for p of x. X minus r times x minus s is r. So we can multiply this out. This is x squared minus r plus s times x plus rs minus r equals 0. Notice I just subtracted this r from the right-hand side to make this 0. Now we really have our quadratic equation, and why I put this r plus s in the front is because, well, we just want it in this form. Now we can really solve b squared minus 4ac. In this case, b squared minus 4ac, this is negative r plus s squared, because this is the b here, the coefficient, that's not s, x, and then this is minus 4ac. The coefficient here is 1, so we just care about this here. rs minus r equals 0. Now, when we really square this, this negative cancels out. So what we get when multiplying this out, we get r squared plus s squared plus 2rs minus 4rs plus 4r is 0. Well, now these two cancel, so r minus s squared plus 4r, I should move it to the other side. This is equal to negative 4r. And I'll explain what I did here. Well, 2rs minus 4rs, this is negative 2rs. Now, we can use the negative 2rs with r squared and s squared to make r minus s squared. We have a 4r left over. Now we move it to the other side. So we have negative 4r. We can take the square root. So r minus s is equal to the positive or negative 2 times the square root of negative r. Because this is negative r, becomes 2 plus or minus. Okay. Well, from this, we get that s is equal to r plus or minus 2 times the square root of negative r. Now, this might seem a bit weird, but this is eventually what we get to evaluate s. And we'll need this later on in the video. Okay, now we're on to the next leg of the problem, and most likely the last, but the closest to last right now. Okay, so, well, p of ln of x, this is like, this is the polynomial where we want the roots that are the greatest, and s and r are the roots. Well, now, to get the greatest roots, the sum of the roots, we have to use the plus only. And remember, we want the sum of the roots, so this is r plus s. We know that s is equal to r plus 2 times the square root of negative r. So this is really 2r plus 2 times the square root of negative r. Okay, that's pretty straightforward. Well, now, yeah, that is correct. So we have this formula for r and s. Pretty simple. Well, now we don't want this this square root here. This looks pretty weird. So we let a be equal to negative square root of r. Now we can really evaluate this. Well, negative. Okay, so 2r here. 2r. Okay, let's just start with the value of r. A is equal to the square root of negative r. This means that a squared is equal to negative r. So that means that negative a squared is equal to r. So we can substitute this value in there. So from here, we get that this is equal to negative 2a squared. And we can factor the negative 2 out, and then this is going to be minus a. Now, what we can do is we want to factor this into a quadratic. Well, one value that works here, the possibility, the only value is 1/2. So we subtracted here, we have to add 1/4. Negative 2 times 1/4, that's basically subtracting 1/2. So now we have to add 1/2 to keep the value the same. Well, now we see that this is negative 2 times a minus 1/2 squared plus 1/2. Here we see that a equals 1/2. This works. A equals 1/2. And we can use this information to find out information about r and s. Okay, we have all our data written down. A is equal to 1/2, a squared is equal to negative r, and negative a squared is r. Well, this is pretty straightforward. We can just solve for r. R is negative a squared, so negative 1/4, this is r. We have r, We want to find S now. S is r plus 2 times the square root of negative r. Okay. So S is, we can substitute the value of r. This is negative 1/4 plus 2 times, well, negative r is equal to a squared. This is 1/4. So 2 times the square root of 1/4 in here. So S is equal to negative 1/4 plus, well, when you bring this in, this is just 1. So plus 1. So S is equal to 3/4. We have R and S. We can just bring them into the original formula. Well, yeah. So X minus R, this is plus 1/4 times S, not S, sorry, X minus 3/4. Okay. This gives us X squared minus 3x over 4, I'll just write it like this, plus x over 4 minus 3 over 16. Now, the question asks when p of 1 is, when x is 1. So we can just substitute the value of 1 here. This is 1 minus 3/4 plus 1/4 minus 3 over 16. When we solve this, this will get our answer 5 divided by 16. This problem's challenging, but we did it.